Hello, everybody. Nice to see you. And it's episode 9, Project 2, The Joy of Functional Game Dev. And today we have to go a little bit faster, probably going to be about half an hour or so, because time is short today. We're in the start of episode 9 is tag V0.8.1 on the GitHub repository. And moving on, we got some more of the dispose stuff taken care of. As far as our Trello board, there are plenty of things we have, but one of the things we just really don't have is a game. And this has bothered me. I've wrestled with it since starting the project. It's like, well, I don't really have a good game idea. And that the ones that I do think of, like, oh, that's a bit on the elaborate side, and I don't want to have to struggle with both making the SDL2 wrapper and making a heavier or even a medium weight game. So I'm not going to. I'm declaring that this month's project is the SDL2 binding, or at least a first version of it. And the rest of this is, but in order to really test out, hey, do I have a good binding? I need a real example of a game. So I will just reach into my bag and pull out some games that are quite simple to make and based on where we are currently at. And that's what I'm going to do. Okay, and perhaps one of the fastest ways to do that, see if I can find my, in order to do this, what I need is a bitmap. I need a particular bitmap. Oh, such wonderful things I've got. There you go. I'm going to copy you. Yes. All right. So, all right. I'm going to copy you right here. And this, everyone, is open with paint.net. Of course, you can't see it, and that's okay. We're going to add a layer. We're going to put that layer underneath. We're going to fill it with black, and suddenly everything's going to make more sense. All right. When in doubt, go ASCII. All right. And flatten you. And at the moment, I only have the ability to open BMP files. But that's okay. All right. So I got a round font 8x8. You may go. Copy you into project 2, and for the moment, let's get ourselves spitting out a screen full of random ASCII graphics every frame. That's always the first part. I have a friend who has been known to say that similar to how Godzilla always starts with a C, a particular one of my games called Jet Lag always starts with random ASCII graphics being shown on the screen. Okay, gonna do you there. content is back. Content, add existing item. Start.bmp. There you go. Add you. You are a copy if newer. All right. Now, I'm going to give you a super quick tour of what I have done. For one thing, I noticed that everything, windows, renders, textures, and surfaces, all had basically the same pattern. There's an int pointer, and I needed a function to destroy it, and I need to dispose it. And so I came up with this pointer wrapper, for lack of a better term. I just called pointer. And that when you're constructing it, it takes one such pointer and a function that will destroy it, and then when it disposes, it does the destruction. Now you go over to SDL window, and whenever you create it, you're going to make a pointer with the pointer that you get from the create window function and destroy window function. Similarly with surface, same basic idea, where it's create a RGB, create RGB, make a pointer, which is that, wrap it up with one of these guys. And same story with create, so pointer, wrap it. There's from surface, pointer, wrap it. Now I could have gone with different different constructors or whatever, or different. So I don't even know how to do that. I know how to make the one constructor. But in any case, I made functions that spit out these objects. And this makes it much less functional to my mind, especially because here's a mutable Windows pointer, because when it's destroyed, if it is a zero pointer, I don't want you to do anything. I don't want you to call anything, and after destroy function, it has to update it. But I think that's just here's a system-wide resource, and I don't see really any way around using mutable state here. I always feel defeated when I don't find a way. But that's how it goes. And even renderer takes those, and then a lot of these things now, it's SDL window dot window, and so it has to grab the pointer value off of the object. So it's just a bit of refactoring there. But and one other one. Here in SDL, I made an object called system. Well, it's not really an object. It is, yet it is not. It doesn't hold anything. It is a stateless object. The whole point of it, and this one does have a couple extra functions, but the system, calls my SDL init, and disposing of it calls SDL quit. So all I have to do in my program is say use system and pass along my flags. There is no quit. Later on, when it disposes, it quits. So now all of these things are uses, and I'm not entirely sure what sort of consequences this has for the surfaces that I want to maybe load on the fly, but we're not going to worry too much about that just now. Right now, how tall is that image? At the moment, how tall are we? Is there any way to tell? I look around the screen and I see it's no good, worthless. Alright, we're going to go to paint.net. Open it. Project 2, content. What are you? You are 256 by 256. Which means that your cells are 16 by 16. cells are 16 by 16, which means, yeah, I built it out of 2 by 2 blocks. And which is the original spec of how I first made this image. I didn't exactly, well, yeah, I made the image. So I'm actually going to resize it down to 128 by 128. I'm going to nearest neighbor and hope it all works out. And let's zoom out. Control 0. And we look to be okay. Okay, yep, everything's groovy. We're going to save it like this. So now, I literally have an 8 by 8 section is one graphic. And hey, while we're at it, let's have a bitmap. Equals. And where do I have it? Steel surface. Load bitmap. And the format that I want is that. Content ROM font 8.bmp. There's that. I need to put, so it's 128 by 128. And I think I'm going to double this. 240. 320 by 240. So what I'm doing here is I'm setting the logical size of the screen. So I'm going to make it even grainier than it is. So it's 640 by 480. But I'm setting the logical size to be 320 by 240. And that's what I'm going to render to on my main surface. And the reason I want to do that is to give it a blown up look, but so that I only have to work with the small, with smaller graphics. And this is how I like to work because I'm retro like that. I got a bitmap. And my render, I got a render state here. All right. Bitmap, steel surface. That will make this program make this angry. Okay. Now we don't yet trust that that this is a we don't yet trust that this actually renders. So okay, we're gonna be done with this game state crap. Okay, we do still have to do all these things. I don't have to do these. Context surface. DL surface. Lit. So I need a rectangle. And this is a fairly awful way. Blit is an awful upper blit. It's source, dest. Okay. I just absolutely hate it. So back over here to render. So my source rectangle is none. My map. The destination is 0. I can type. Equals 128. Height equals 128. And he goes, I don't know what you're talking about. Because that's not a rectangle. Rectangles have PXs. Oh, contact surface is already there, so I do that, and then I ignore Ugbuyer. What are you? Does not contain field X. Some. Alright. So it should split the source of the entire surface onto that area of, so that part of that context bitmap goes onto that part of my surface. I also don't need to handle events whereby I change these. I no longer care. I may care in a little bit. Hey, look at you. Got the bitmap loaded, so we can trust that. Now we need a manner um, of dividing it up. So I need source rectangles and a surface. So what I want to do here, and I want to be able to refer to them. So basically, I'm saying, hey, here's tile base graphics. So I want some way of saying, and I'll put this type right in here because it's going to be part of my rendering context. So a type sprite equals, and this won't be entirely complete. Source surface, which is a STL surface dot DL surface dot surface. Do I really even need the name source surface? What other surface are we using here? And a there's the bounds, which is a STL geometry rectangle option. More or less, here's the parameter for here are the two parameters for blitting. And what I want to do here, and we're going to have sprites, which will be a map of int to sprite. Okay. So now it's a, well, what? And you know what? We'll even throw a random on here. All right. Now my sprites are going to be a map of that to that, so I'm going to need and as well as on the end, we're just going to context.sprites dot context dot random going to be 256 of them. Whoa, what are you? Oh. So let's go with, here's the sprite. Sprite equal that. It's going to be sprite dot bounds and sprite dot surface. And that all works. Now I just need to set up right now. This doesn't know it should be angry because compiler ain't got there yet. And the random will equal new system.random. And so what I'll need is sprites equal sprites. And what will sprites be? So let sprites equal, and we'll start with a sequence, 255. And that's going to be sequence.map fun index. Create a tuple, first of which is index, and the second of which is because this is the neatest deal of pixel, do it. Hey, let's get these bad boys together, huh? I do still need SDL geometry. Well, what if I just say just random? So surface equals bitmap bounds equals some whatever equals width equals always 8px, width and height are always 8. 8px. So it's 8px, 8px times something. Did I do it wrong? What am I doing wrong here? Right, so there's a surface and a bounds. I don't. Well, we'll get this done right. Times something, and this is also going to be times something times index mod 16 and index div 16. That is the mod function, right? I hope. I haven't used the mod function in F# the whole time. Haven't used it. Okay, what are you? What are you? Up, no. What is that one? Bounds equals that. Surface equals bitmap. Space? I don't know. Well, how about when in doubt? Let create sprite. Surface bounds equal surface equals surface bounds equals bounds. we'll do that. Bitmap and the sum. I need that one. There you are. You're there. Sum. My goodness. What in the world? Huh? Well, then this one is map. Oh, it's still render. That's render. Create sprite. So now you are a map of int and render sprites. And now you're cool. All right. And in my rendering, so I want to split things. I don't want to do that exactly. And I don't do for loops, kids. So let's look them up right quick. For in. For in do whatever. All right. For in do. I want for x in 0. So at 320, 320 divided by 8, 320 divided by 8 minus 1, 39. Do for y in 0 to, it's 240 divided by 8, so 29. Do x times and y times. Let's do that. So different sprite each time. Random sprite. Fixed location. Do your build. And this is likely something that's not going to show very well on the YouTubes. Go. And yes, sir. Looks kind of like static, but if you look at it here, you can see little characters going very quickly. It's really pretty good. No, I don't have a frame rate counter. Why'd you ask? And I don't bother with a frame rate counter. Like, oh, good, I got 80,000 frames a second. I don't care. Really don't. So so that's good. We loop through and we draw some. Ooh, why are we 8 and 8? Why are we 128? Go faster even. Okay, and that is pretty good. That's a pretty good rate. For our next trick, we want to get some color in there because of black and white ASCII graphics are no fun. Or there's a lot you can do within that. And then also we want to be able to render some. We want a more or less an ASCII tile map so that we can know what goes. So we can lay it out on a screen and have it persist. That'll work into our game state. But that's the time I've got today. Thanks for coming along on this journey with me. And as always, keep the joy of functional game dev in your heart, and we'll see you next time.